In class today, I asked you guys to read this section, and so I just want to go through a few of the important things, and then I'm going to go through the examples with you. So a major reason for finding a particular equation of a sinusoid is to use it to evaluate y for a given x value, or to calculate x when you are given y. So that's the whole reason why we're doing inverses, is so that you can find x. Functions are used this way to make predictions in the real world. For instance, you can express the time of sunrise as a function of the day of the year. With this equation, you can predict the time of sunrise on a given day by simply evaluating the expression. Predicting the days on which the sun rises at a given time is more complicated. In this section, you will learn graphically, numerically, and algebraic ways to find x for a given y. So we're going to learn three different things. We're going to graphically, which you guys are pretty good at that, numerically, and then algebraically. And I think algebraically is kind of the new one that we're going to learn. Okay, so given the information of a circular function or trigonomic function and a particular value of y, find specific values of x or theta, graphically, numerically, and algebraically. So that's really what we're doing. We are going to do this using the inverse cosine function. Sometimes you'll see it written as arc cosine, so I'm just going to write that off to the side. Sometimes you see inverse cosine written as arc cosine. Okay, so if you see that, that means exactly the same thing. So the symbol, the inverse of cosine of 0.3, means the inverse cosine function evaluated at 0.3. A particular arc or an angle whose cosine is 0.3. So this is the arc length. That's the distance, is what it's saying. So we could plug that into our calculator and make sure the calculator is in radian mode. So I'm going to click on mode, and I'm in radians. And if we put in the inverse cosine of 0.3, sure enough, we get this value here. Now, to find all of the values after that, you could add 2 pi. Add another 2 pi. So there is the first value is 1.2 radians, the next value is 2.54 radians, the next value is 13.83, and you can keep adding 2 pi infinitely. And so that's what it's saying right here, that the general solution is plus or minus the inverse cosine of 0.3 plus 2 pi. So we can add 2 pi as many times as we want, and we are going to get different solutions for this. And those solutions are all radians. Okay? The sign plus or minus tells you that both the value from the calculator and its opposite are values. The 2 pi n tells you that the arc, that is an integer number of revolutions added. So 2 pi n, so if you put a 1 in for n, that'd be 1 revolution. If you put 2 in for n, that'd be 2 revolutions. 3 would be 3 revolutions, and so forth. The arc sine and arc tangent relations will be defined later. And so right now we are going to solve everything using arc cosine. And the reason for that is because arc cosine has the positive value and the opposite. Sine and tangent are not just the positive value and its opposite. You have to do some other funky stuff. So we'll learn more about those later. So here's our definition of arc cosine. The arc cosine of x is plus and minus the arc cosine plus 2 pi n, or if we're talking in degrees, that's what it is in degrees. Remember, n is an integer, which just means whole numbers. Okay? Alright, so that, I believe, is everything that you were going to read, and then the rest of it are just examples. I guess there's a little more up here. The function value of the inverse of cosine of x is called the principal value of the inverse cosine. So the one what that's saying is the one that pops out of the calculator, that's the principal value. That's kind of your starting value, and then you can add and subtract the period from there. This is the value the calculator is programmed to give you, and we're going to learn why certain quadrants are picked from these inverse function values. So now I'm going to grab a different piece of paper, and we're going to work through these together. And so the first one that we are going to do would be example 1. And it says find the first 5 positive values of arc cosine of negative 0.3. So find the first 5 positive values. Well, let's go ahead and take our calculator, and we're going to do the arc cosine of negative 0.3. And our first positive value is 1.87. So I'll put x equals 1.875. And how do we find our next positive value? Well, you add 2 pi to it. So when we add 2 pi, our next value is going to be 8.158. How do I find my next value? I add 2 pi. And we can keep doing this until we get 4 or 5 positive values. So add another 2 pi. And why am I adding 2 pi? What's the point? 2 pi is 1 full revolution. Every 2 pi is an angle that is coterminal. So those are our first 5 positive values, and let's just check with the example and see if we did it right. So this says take the arc cosine and then add 2 pi n, and so by calculator you get 1.8754, and so you just keep adding 2 pi n, and here we have it, 1.8754, 8.158, 14.442, 4 point, I don't know where that came from. Oh, they started to take the negative ones. That's what they were doing. And so that's where those other ones came from, is they took the negative arc cosine of 0.3. That is not a positive value, but you know what? If you add 2 pi to that, that is. And that is another one. So remember, you can take both the positive and the negative values and get solutions from it. There we go. 4.40, that's where this comes from. So these ones are coming from the negative arc cosine, or inverse cosine, and these ones are coming from the positive. And then they put them in order. Do not round the value of the inverse of cosine of negative 0.3 before adding the multiples of 2 pi. An efficient way to do this in your calculator is to press arc cosine of negative 0.3. You get this, and then just do answer plus 2 pi, answer plus 2 pi, and then before we do the negative side. And that's what we just did on the calculator. Okay, so that's how you're going to find your first 5 values when you know why. So in the figure 3.6b, it shows a sinusoid with a horizontal line drawn at y equals 5. The horizontal line cuts the part of the sinusoid shown at 6 different points. Each point corresponds to a value of x for which y equals 5. The next example will show you how to find the values of x by 3 different methods. So our first method, this is example 2, is graphically find the 6 different values. And so those 6 different values are where they have the dots already for us. And so really, in this, we are estimating. So our first one is right here, and that looks like it's at about 4.5. So I'm going to put x equals negative 4.5, because it's right in between 4 and 5. And that's what we're doing graphically. Graphically, we're just finding that point of intersection. This one looks like it's at about negative 0.5. This one looks like it's at about, I would say 8, 9, 10, about 8.5. And that makes this one at about 11, 12.5. And when you're finding these graphically, of course you're estimating. Like, these are not exact by any means. Here's our next one that's graphically, and so that is 21.5. And then lastly, this is 25.5. Okay, and you will see some patterns there, like these are one full period away from each other, and then these ones are one full period away from each other. So yeah. Alright, so graphically, you just look at the graph and you figure out what is the point of intersection, and then you can write those down. And of course, those are going to be an estimate. Okay. And so up here at the top of this page, it just confirms what we said, that the values are about negative 4.5, negative 0.5, 8.5, 12.5, and 21.5 and 25.5, which is exactly what we wrote right here. So we know we did it correctly. All right. So graphically, you just look at the graph and you go from there. The next method is numerically. So find the 6 values of x in example 2, show that the answers that you agree with the ones that we found graphically. So in order to do it numerically, you need to write an equation. So this is the particular equation. We could have gotten that by looking at this graph. And so if we look at this graph, we can see that one full period goes from negative 0.5 to 12.5, and then you can find your b value, and then you can find that the amplitude goes from 2 to 16, and so our amplitude has to be 7, because that's a distance of 14. So you can find all those points, and in the end, here is our equation. Now when you're numerically doing this, really the calculator is doing the work for you. You are going to go into your graphing calculator, and you are going to put your particular equation that you just found. So 9 plus 7 times the cosine of 2, remember put these in parentheses, 2 pi over 13 times x minus 4. So there's our particular equation, and we are looking for when this equals 5. How do I know that? Because that's where this line is drawn, is at y equals 5. And so we want to know what are all these points of intersection. So I'm going to just check my window real quick and make sure that it matches. So I want to go from negative 5 up until at least 25, but probably 30. And it looks like they're going up by 1, so I'll keep the 1s. And then my y min looks like it's 0, and we're going to go up to at least 16, and again it looks like they're going by 1s. So I just changed my scale to look like this scale here. Now I'll click on graph, and hopefully my graph looks the same as theirs. And it does, just on a little bit smaller screen. Okay, so when you are solving these numerically, you just use your calculator and its tools. So that button right there says calculate. If you hit second trace, it brings you to the calculate screen, and you're going to go to intersect. Now it prompts you down here 3 different things to do. So we want to go over as close as we can get to that first point of intersection. And it says first curve because it wants you to get as close as you can on the first line as possible. Then it says second curve, and you see how that turned red? That's because now I'm on the red line. And so again, as close as you can. And then the last thing says guess, and so as long as you're on there, hit enter. And it says that point of intersection is at negative 4.491531. So I would say that we probably estimated fairly close. We are going to do that for all of these different values. So I'm going to go into that menu again, and I'm going to go to the second point of intersection. So 3 times, and we get negative 0.508. Again, I would say we're pretty close. It's hard to see. We're going to do the same thing. Go into that intersect mode again and go over to the next point. And so we're going to do this for every one of these points and make sure that we estimated correctly. Okay, we did. Okay, 12.49, I would say that's pretty close. So at this point, I want you guys to pause the video and finish checking for those other ones on your own. Okay, in this last part of the video, we are going to find algebraically, so that means by calculations, the 6 values of x in example 2. Show again that the answers agree with what we found in 2 and 3. So remember, example 2 was graphically finding them, and example 3 was numerically. So this is arguably the most difficult part, and even I struggle here once in a while. The first thing to remember is that the arc cosine, and that's what we're doing here, is we're doing arc cosine, is always the plus and the minus. And so if you remember back to that little box that we had that the definition was plus and minus the arc cosine of whatever the value was plus 2 pi. And that's when 2 pi is your period. And so if we have a different period, like in the case of this one, that's going to come into play. So we are going to work through this together, and even I struggle once in a while with this. So if you're struggling, that's okay. It's just going to take a lot of practice. So we are isolating our x value. That's what we're doing. And so the first few steps are just normal algebra. We're going to subtract 9 from both sides. And keep your work nice and organized. So that cancels out, and we have 7 cosine of 2 pi over 13, and that was just our equation that we had already built, equals 5 minus 9 is -4. Okay? And still just going with the algebra, we're trying to isolate the cosine. We're going to divide by 7 on both sides. So these 7's cancel out. And keep your work nice and neat. And so now we have cosine of 2 pi over 13, x minus 4 equals -4/7. And for now, I would just leave that as a fraction. We can't reduce it. And so for now, I would just leave it like that. At this point, we have our cosine that's isolated. Remember, both of these things are inside of the argument of cosine. And so you're not going to add 4, you're not going to divide. You have to get rid of that cosine first. So at this point is when you're going to take the arc cosine of both sides. So I'll start writing steps now. Take arc cosine of both sides. And remember, when you take the arc cosine, it'll be plus and minus that number. And then even more specifically, when you take the arc cosine of that number, you're going to add 2 pi n to it. So the arc cosine, let's see if I have a different color over here. I do. The arc cosine here, or the inverse cosine, and we'll do it here. So these cancel out, and you're left with 2 pi over 13 times x minus 4 equals plus or minus the inverse cosine of -4 over 7. Okay? Now we can start getting rid of the rest of this. So we can multiply by 13 over 2 pi, or you can multiply by 13 and divide by 2 pi. When I get rid of this, I would just multiply by the reciprocal. So if I multiply by 13 over 2 pi, that would cancel this out. And we're going to multiply the positive and the negative. This isn't a plus and minus. This is the positive and negative over 13 over 2 pi. If you need to pause the video at any point so that you can see the steps that I'm doing, feel free. This is also worked out in your book, and so you can check the work in your book as well. Okay, so that's what we have right now. Oh, I forgot a step. As soon as you take that arc cosine, you're going to put plus 2 pi n in here. There we go. Because that arc cosine is going to be not only this value, the plus and the minus of it, but all the other values that are 2 pi away from there. There's only one other thing to do here, and that's to add 4. So x equals 4 plus or minus oh, what am I doing? 4 plus, sorry, 13 over 2 pi times the plus or minus arc cosine of negative 4/7 plus 2 pi n. Now we could distribute this in, and that might make it look a little bit prettier, but you don't have to distribute it in. You could leave it like this. So here is one possible answer, and I'll write that on here, one possible answer. Okay? Another possible answer would be to distribute this in. And when we distribute that in, you'd have 4. Now it's going to be plus or minus 13 over 2 pi times the arc cosine of negative 4/7 plus 13, because when you distribute this in, the 2 pi's would cancel out, so 13n. That's one more possible answer. It just depends on if you distribute it in. Okay? And then this question specifically said check these answers with the examples 2 and 3. So let's just take a few of these. Let's take our calculator and we'll plug in 4 plus 13 over 2 pi. Oops. Do you see how many parentheses I have here? Because this has to be in parentheses. Times the arc cosine, or the inverse cosine, of negative 4/7. Let's do that one first and hit enter. We get 8.5. Was that one of our answers that we had originally said? So I gotta flip back to where we were. And look at that, 8.5 was one of our original answers. Okay, and then we can add 13 to that, and was 21.5 an original answer? It was. And you can keep adding 13 to that. This is beyond what we were doing. Now to get the other piece of it, you're going to go back up here, but change the plus sign. You see where my cursor is? Change that plus sign to a minus sign. Negative 0.5, and look at that, there it is. And then we can add 13, 12.49, 12.5. And then you can add 13, and there it is. So, to algebraically solve, you'll isolate the cosine and everything that's inside of it, then you'll arc sine it, and this is where it gets a little bit tricky. Make sure you add that 2 pi n in there, and then just algebraically solve it out. Okay, I think it might be wise to do another example together. So let's do question 5 from your homework assignment. And question 5 has all of these parts here. So it says A, estimate graphically. We did that in our notes. Find the particular equation. Find the x values numerically. So remember, numerically means plug that particular equation in and find where it crosses. Find the x values algebraically. That's going to be the new part that'll be a little bit more challenging. And then find the first value of x greater than 100 for which y equals the given y value. So if we look at question 5, the given y value is y equals 6. And they even drew out the line for us. So A says estimate graphically, and so we are just going to be looking at our graph and estimating. And so let me zoom in here, and we'll just refer back to those questions as necessary. There we go. Hopefully that's a little bit easier for you to see. So estimating those values graphically, you are going to be looking at each place that it crosses. And so there are 4 different places in which they intersect on here. So we are going to estimate those. Now this looks like it crosses at 1. This looks like it crosses at 5. This looks like it crosses at 21. And this looks like it crosses at 25. And so that was estimating graphically. I'll put that next to here. So estimating graphically. Okay. So estimate graphically, you look at where they cross on the graph, and then you figure out what those x values are. Now B is to find the particular equation, and so to find the particular equation, you have to find your amplitude, you have to find your period, you have to find your shift, up and down and left and right. So when we're solving these, we always want to find the cosine. We always want to find the cosine. We don't know how to do the arc sine yet. And so we want to do the cosine because the cosine has that nice and pretty plus and minus. So if we're looking at the cosine function of this, the shift has to be right here because that's where the first maximum is. So we know that the phase shift is -3. So we're moving right 3. Well, the phase shift is 3. It'll be -3 in the function. Okay. We need to find our amplitude. It looks like our maximum is at 7. Our minimum is at -3. So that's a distance of 10, which means our amplitude is half of that. So our amplitude should be 5. Our vertical shift would then be at 2 because that's where the sinusoidal axis is. And lastly, the period. So here is 3, here is 23, so our period is 20. To find B is 2 pi over 20, so pi over 10. So now we have enough information to write our particular equation. So what we have is y equals 2 plus 5 cosine of pi over 10 x minus 3. There's our particular equation. Let's plug it into our calculator and make sure that it does map up like we expect it to. So I'm going to make sure my calculator's in radian mode. Now I'm going to plug this in, 2 plus 5 times cosine of pi over 10, oops, and then x minus 3. And one thing that you'll notice is the parentheses. So I have parentheses around pi over 10, okay? And then I have parentheses around this, but then all of that is inside of the argument of cosine. I'm going to change my window to match this. My negative x value is -3. It goes up to 25, 26, 27, 28, 29, 30. Goes up by ones. My lowest y value is -3, and I go up to 7, going up by ones. Now hopefully this graph looks like the one that's graphed on our paper. And I'd say that it does. In the second y equals, put this number here. That allows us to calculate intersection points. Now using the graphing capabilities on our calculator, if you hit second and then this trace button right above it says calculate, so if we go into the calculate menu, we can go down to intersect. Hit enter. And now just get as close as you can to that first point. So right around there. And I'm going to hit enter 3 times because it prompts me 3 different times. So first curve, second curve, guess. And that first intersection is at 0.95. So this is C. I forgot to tell you guys, we're on C now, which is to numerically find this. So the first one is at 0.95. And we'll do it again with the next one. I'm just going to go back into that intersect mode. And I'm going to the second point, and I'll hit enter 3 times. 1, 2, 3. And that is 5.04. And then I'm going to go to the next one. takes a while to get over there. Okay, and I'm going to hit enter 3 times. So 20.95. And lastly, one more time, and we're going to hit enter 3 times. And there we have it. Okay, I'm going to move the calculator off to the side. So, we found them numerically. And these do match up pretty well. 0.95 and 1, that's pretty close. 5.04 and 5, that's pretty close. 20.95 and 21, again pretty close. And then 25.04 and 25, so pretty close. So this was numerically. And next that'll put using calculator. Alright, D, find the x values algebraically. Alright, so algebraically is going to be probably the most difficult. So when we solve this algebraically, we know that this is supposed to equal 6. So we're going to say 6 equals, and then this is our equation. 2 plus 5 cosine pi over 10 x minus 3. Now start peeling away until you have cosine and its argument left. So start peeling things away until you have cosine and its argument left. So we're going to subtract 2. That leaves us with 4 equals 5 cosine pi over 10 x minus 3. We do not have cosine and its argument left yet. So we need to divide by 5. So we have 4/5 equals cosine pi over 10 x minus 3. And now we have cosine and its argument left. So we can take the arc cosine, or the inverse cosine. Remember, arc cosine and inverse cosine are exactly the same thing. Okay? Now, as soon as you take that arc cosine, or the inverse cosine, put a plus and minus here, and then plus 2 pi here. That's saying that not only do I have this value, but I have the plus and the minus of this value, and then you're going to add 2 pi every time because those are all the different rotations or revolutions. Okay, now we can get x alone. So we're going to multiply by 10 over pi, because that would cancel these out. So we'll multiply this by 10 over pi, which we could just distribute that in now even. And if we did, this becomes plus or minus 10 pi, the inverse cosine of 4/5, plus, off to the side I'll do that, 10 times 2 pi over pi. The pi's cancel out, and so that should be 20. And one thing that you'll notice is that this number here, every single time is your period. We already said the period is 20, and that's where that comes from. We have x minus 3. We're still trying to get x alone, and so we're going to add 3. And when you add 3, just go ahead and put it before the plus or minus. So our final answer would be x equals 3 plus or minus 10 over pi cosine inverse 4/5 plus 20. Now, it would definitely be wise to check your work. So I would take my calculator and I would plug this in, 3 plus. Make sure you put your parentheses in all the right spots, otherwise weird things happen. Okay. Was 25.04 one of our options? Yes. So we know that we created the correct equation, and this represents all solutions. Now, it's a little bit weird. Normally when we're solving, we don't have something weird like this. But remember, as this sinusoidal graph keeps on going, it's going to have infinite solutions. Oh no, you need to have an n here. That's what's going to represent all of the infinite solutions. So it's going to have infinite solutions, and it's just going to keep going and going and going and going. All right, the last part is find the first integer that is over 100. So we have this first value here. Keep adding 20, that's your period, until you get your first number that's over 100. And look at that, we have 105.04, but that might not be the first value. Because what if the negative of this gave us our first value? So I'm going to go in here and switch this to a negative. And now I'm going to add 20 until I get to my first value over 100. And there it is. There's the first value that's above 100. So you want to check both the positive and the negative and add to your period until you get a value over 100. And then take the one that's smaller. And so this time I added the negative. That's what that was. But the first time I added the positive. And that's where those two different equations came from.